Okay, so graphs. This is still 11-1. 11-1. I am on page 678. And the graph of an inverse relationship. So as you increase the independent variable, the dependent variable goes down. As you increase the value of x, y goes down. Remember my first example on the previous video was 1 and 16, 2 and 8, 4 and 4. So 1, 2, 4. 1, 2, 4. As x went up, y came down. 16, 8, 4. Okay. So that's a classic inverse relationship. There are a lot of these things in nature. In my physics class, force equals mass times acceleration. For the same force, as you increase the mass, the acceleration decreases. As mass goes up, acceleration goes down for the same force. When you get into chemistry, these things with what are called gas laws, pressure and volume. If you press down in a confined space, then the gas cannot escape. And then as the space gets tighter and tighter and tighter, less and less volume, the pressure goes up. Think about it. So as one goes up, one gets bigger, or in this case, as the volume gets smaller, the pressure goes up. But anyhow, there's lots of examples of stuff like this in nature. Okay, this is called a hyperbola. I run into hyperbolas and parabolas in things like space and orbits and stuff like this, which is really cool. The trajectory of the spacecraft could have a hyperbolic, which is not good. Depending on what you want, of course. I suppose it could be good. Or a parabolic, or an elliptical. You get all these curve shapes that apply to such cool things like space and orbit and things. Anyhow, it could be on either. If you have it over here, you could also have another hyperbola over here, or it could be in these quadrants. But these are hyperbola. The shape is hyperbola, as opposed to a direct relationship, which, as you know, is linear. Okay, it could either have a positive slope or a negative slope, a positive value for k or a negative value for k. Okay. Alrighty, let's do an example. So it says we're going to graph an inverse variation where y equals 8 when x equals 3. So y equals 8 when x equals 3, and that means that k must equal what equals x times y, which is 3 times 8 equals 24. So your k value is 24. Now I can easily come up with a data table. Let's write this in terms of y. And so y equals 24 all over x. Okay. And now I'm going to come up with a data table here. And I'm going to pick some x values: -12, -8, -4, -2, -12, -8, -4, -2, 0, and 2, 4, 6, 8, 12. 2, 4, 6, 8. Oopsie, did I forget the 6? Oh, sorry, 2, 3, 6, 12. I'll use that. 2, 3, 6, 12. So there's your data. So you have -12, -8, -4, -2, 0, 2, 3, 6, 12. Let's calculate the corresponding y values. So remember, we just put in x here and calculate it. 24 divided by -12 is -2. 24, again, I just put in -12 for x right here. And hopefully I don't get these wrong. 24 divided by -8 is -3. 24 divided by negative 4 is negative 6. 24 divided by negative 2 is negative 12. Notice that this is undefined. You cannot divide by 0. And I should have pointed that out on the previous graph that I had up here. Notice that the inverse relationships did not go through 0. That it's undefined there. And then we get, well, 24 divided by 2 is 12. 24 divided by 3 is 8. 24 divided by 6 is 4. 24 divided by 12 is 2. And now we can graph this. So I'm going to go up by 3s. 3, 6, 9, 12. Three, 6, 9, 12, 3, 6, 9, 12, negative 3, negative 6, negative 9, negative 12. And negative 3, negative 6, negative 9, negative 12. Oops. Okay, let's just graph it and just see what this looks like, and then we'll be done. Okay. Well, here. X is negative 12. Y is negative 2. It's going to be down here somewhere. All right, it could be down there somewhere. X is negative 8. Y is negative 3. It's going to be here-ish. Close enough for government work. Y is negative 4. X is negative 4. Y is negative 6. It's going to be right around here. And negative 2. Oh gosh, that's a mistake. 24 divided by negative, when x is negative 2, remember, I'm sorry, I screwed up. So y equals 24 all over x. When x is negative 2, y is negative 12. I made a mistake on that, sorry about that. So that would be down here. You can see the graph here, and again, it doesn't touch 0. So there's the value when x is negative. Y is negative. When would it be in these two quadrants? When there's a negative sign in the equation. When there's a negative sign in the equation, it would have ended up in these two quadrants. So let's plot these points. When x is equal to 2, y is equal to 12. Good enough. When x is equal to 3, y is equal to 8. Right around here. When x is equal to 6, y is equal to 4, be around here somewhere. And when x is equal to 12, y is equal to 2, would be right around here somewhere. Okay? There we go. So these are this is the graph for this function, and it is a function. It does pass the vertical line test, all right? And the one thing is that they never hit 0. They never, ever, ever hit 0 in a situation like this. We'll look at transformations another time. Okay, we're done.